Imagine you are falling. Ahead of you is the darkest object in the universe, a place where the rules break down, where time bends, and where the very idea of a future stops existing. Tonight, you are going to fall into a black hole, and I am going to tell you, second by second, exactly what happens to you. First, what actually is a black hole? It is what remains when a giant star dies and collapses under its own gravity. All of its mass is crushed into a point so dense that nothing, not even light, is fast enough to escape it. They are born in an instant of unimaginable violence. When a star far heavier than the sun burns through its fuel, its core collapses in less than a single second, and out of that catastrophe, a point of infinite gravity is left behind. This is not science fiction. In 2019, humanity took the first real photograph of one at the heart of a distant galaxy. That dark circle is a shadow, cast onto a ring of superheated gas falling to its death. And they are not rare curiosities. They come in a range of sizes almost as extreme as the objects themselves. From stellar black holes, a few times heavier than our sun, to supermassive giants, billions of times heavier, sitting at the hearts of entire galaxies. The boundary around a black hole has a name: the event horizon. It is not a surface you can touch. It is a line in empty space, and it marks the ultimate point of no return. The very first black hole we ever found has a name: Cygnus X1. We cannot see it directly, but we can see its victim, a giant blue companion star being slowly stripped and devoured, its stolen gas screaming in X-rays as it falls. Cross it, and to escape, you would have to travel faster than light. And nothing can travel faster than light. So once you pass this line, there is no coming back. Not for you. Not for anything. So let us begin the fall. You are floating in space, far from the black hole, falling feet first toward it. At first, nothing seems strange at all. You feel weightless, peaceful even. But as you get closer, something eerie begins to happen to the light around you. The black hole's gravity is so strong that it bends the path of light itself, warping the entire sky into a swirling ring around the darkness. The gas spiraling inward piles up into a disk, and that disk becomes one of the brightest things in all of creation. Friction heats it to millions of degrees until it blazes across the cosmos. When we see these feeding giants from far away, we call them quasars. Stars that are actually behind the black hole appear smeared around its edges. You can see around the object and behind yourself all at once. Your sense of up and down begins to dissolve. Some black holes do something even more spectacular. They fire titanic jets from their poles, beams of superheated plasma blasting outward for thousands of light years, outshining 100 galaxies at once, all powered by the matter falling to its death. And now, the strangest part of the entire journey: time. As you fall closer, gravity begins to slow down. Time for you, compared to everyone watching from far away. This is not a trick. It is real, and it has been measured. And if the black hole is spinning, and nearly all of them are, it drags space and time themselves around with it, like a spoon stirring thick honey. Near the edge, you could not hold still even if you tried. Space itself would sweep you along for the ride. To a friend watching safely from a distance, something impossible happens. You appear to fall slower and slower and slower. Your image freezes at the edge of the black hole, glowing red, and then fades. To them, you never actually fall in. You hang there, frozen, for the rest of eternity. But from your point of view, nothing about time feels strange at all. You keep falling faster than ever, and now you face the danger that will actually kill you, and its name is wonderfully absurd. Spaghettification. The force doing this even has a familiar name: tidal force. It is the very same force the moon uses to pull our oceans into tides each day. Here, near a black hole, it is simply turned up to an unimaginable extreme. Because you are falling feet first, your feet are slightly closer to the black hole than your head. And gravity is so extreme here that your feet are pulled much, much harder than your head. The difference stretches you, gently at first, then violently, until you are pulled into a long, thin strand of atoms, like a piece of cosmic spaghetti falling into the dark. But here is a twist that depends entirely on size. For a small black hole, spaghettification happens long before you reach the event horizon. You would die outside. But for a supermassive black hole, millions of times larger, the tidal forces at the horizon are gentle. Which means, for a truly giant black hole, you could cross the event horizon completely intact without feeling a thing. You would sail across the point of no return, alive, and never even notice the most important moment of your life. And what would you see in that final crossing? Looking back the way you came, the entire history of the outside universe would appear to speed up, playing out in fast forward above you. In your last moments, you would witness the future of everything. So now you are inside, and here our physics falls apart. Inside the event horizon, something bizarre happens to space and time. They swap roles. Moving forward in time now means moving toward the center. The singularity is no longer a place in front of you. It is a moment in your future, as unavoidable as tomorrow. You cannot steer away from it. You cannot fire a rocket to escape it. Every direction you can move, every choice you can make, leads to the same place. The center. And at that center waits the singularity. A point where, according to our current understanding, matter is crushed to infinite density, and space and time simply cease to have any meaning. The honest truth is, no one knows what is really there. Our equations break and give only nonsense. This creates one of the deepest puzzles in all of physics, the information paradox. The laws of nature insist that information can never truly be destroyed. And yet everything that falls into a black hole appears to vanish completely. Even Stephen Hawking wrestled with this for decades. It may be that a black hole hides a doorway. Some physicists have speculated that they could connect to distant parts of the universe, or even to other universes entirely, through a tunnel called a wormhole. There is no evidence. But there is no rule forbidding it either. And astonishingly, black holes may not be entirely silent. In the Perseus galaxy cluster, a supermassive black hole sends pressure waves rippling through space, a note so impossibly deep that it sits 57 octaves below middle C. It is the lowest sound in the known universe. For now, the singularity remains the single greatest mystery in all of physics. It is the one place in the universe where everything we know stops working. To truly understand it, we would need a new theory of reality itself. So that is your journey: the bending of light, the freezing of time, the stretch into spaghetti, and a final, silent fall into a mystery that no human mind has ever solved. And the most humbling part of all, these monsters are not rare. There is one at the center of nearly every galaxy, including our own. Right now, 40,000 light-years away, a giant is quietly turning at the heart of the Milky Way. You will never fall into a black hole. But somewhere out there, in the endless dark, Matter is falling into one at this very moment, crossing a line beyond which its story can never be told. Think about that tonight and get spaced out.